So a sample system, a plant with a control system can be something like this, right? But it's not always that we can represent this to take a lot of space and a whole lot of time to design that, right? So generally we simplify it to something like this, right? And then the writtens and the symbols and everything has its own meaning, right? So we, for systems like that, we design like this, where here is saying that we have these are the inputs, right? And then looking at nothing's attached to it, meaning that it's not controlled. These are the reactants, the concentration, temperature, and then the flow rate, right? And here we are seeing that because the system releases heat, we don't want it to heat your particular beyond a particular temperature or something, right? So you introduce a coolant here, right? So here there's the coolant flow rate, the coolant initial temperature, right? And then the coolant process here gets here. Oh, where is it? That's the wrong part. Passes here, and then this is actually the cooling jacket. It cools this whole system here, and then it exits, and the coolant exits through this part, right? So then we have the coolant final temperature, right? Final flow rate of the coolant, still the coolant flow rate, and then here we have the temperature of the coolant as it exits the system, right? This is a stirrer here, and this is the product. So this one's whatever reaction that takes place here, we have the product here coming out, right? With a particular concentration, a particular temperature, and a particular flow rate, right? So we simplify all the system to something like this, right? And then we say that we having a control system in we introduce control system into plants or facilities because we don't want it to go beyond something that we cannot control, right? So that we end up having accidents in what we see, what happened in the Chernobyl accident, right? Yeah. So what we are seeing here is basically the stability of system. There are some systems that if there's an external disturbance, they're able to stabilize themselves. So like, let's say when we look, so let's look at them. This is, let's say, A, and this is B, right? Yeah. So in A, for instance, what happens is that there are some systems that if there's an external disturbance, right? So let's say the whole operation, as we saw in that particular demonstration that we before this, right? If the whole process is going on, right, but there's a disturbance, right? It's a particular time, let's say TO, right? So this disturbs the whole thing. So let's say if it's in terms of temperature, like for instance, right, this X here could be anything. This is time here, right? So let's say this X here is a temperature, right? And the temperature raises, like rises, right? Because the system is able to control itself, some systems are self-stabilizing, right? The temperature goes up and then it comes down and it goes way below where you want it to be, right? And it comes down. But then looking at the direction, it ends up becoming what you want it to be. So basically, this straight dash line here is the temperature I want it to be, or the set point, or the steady state, right? But there are other systems, and these are the ones that particularly require what they call a control system, right? So this one, for instance, and then let's see. So let's change this to 1 and 2, right? Right. So this is diagram 1, and this is 2, right? So in this one, for instance, it's saying that you have a system. Some of the systems you have, if it's temperature, let's use temperature again. Right? So if it's temperature, as the reaction goes on, if there's a disturbance, the temperature can rise abruptly and then keep on rising. We don't want it that way. This could end up in serious accident, right? Some of them too, either if there's a disturbance, if it's temperature or concentration or whatever, it decreases, and then the reaction, it can get to a point where the reaction will happen again. And there are some of them too, if there's a disturbance, it moves like the disturbance creates some kind of disturbance, and it's this all the disturbance keep on increasing, right? Keep on increasing to the point where it can create a whole disaster that we don't want, right? So basically, these plots are describing the stability of systems. So if it's a self-stabilizing system, as we see in one here, fine, it might not need a control system. But if it happens to be something like this, what we see in this two here, then definitely it needs a control system, right? Yeah. And then these control systems, there are different ways of rearranging them, right? Depending on the system. It's not always that like it's fixed that we have a control system that works for all types of systems, right? It does work like that. For different disturbances or different systems require different control systems, right? So all what that we are seeing here is still kind of like similar to this, still similar to this, right? So we are still having the continuously stirred tank reactor. So in this first one, for instance, you see that we are kind of like heating what's inside. We are having input as kind of like temperature and flow rate, right? And then we have an output flow rate and temperature again. So it seems like we want the output to have a particular temperature and a particular flow rate, and then we are kind of like maintaining the height of it, right? Maintaining the height of the reaction that's happening here, right? right? So looking at this very well, what it sees that this is basically under representation of the system, right? A continuously stirred tank reactor, right? But then we have something here. As we said, we use symbols in representing all this. So what we see here is what we call a valve. So basically we want the temperature of the system to be at a particular temperature, right? So the steam is basically the heating, what we use to heat the liquid or whatever the fluid is in the system, right? So if we see that uh, the temperature of the fluid in the system is low, right? If the temperature is low, so if temperature is low, so if it's low temperature, we can open the valve more, right? Which is this here, the valve. Or if the temperature is too high, right? If the temperature is too high, then we can close the valve a bit, right? So that we get too close to what we are doing. And there are a whole lot of ways of doing it. Some of these control systems are manually operated, some of them are computerized. There are a whole lot of things, right? So this is what we see. Basically, this one here is a valve, and it's a control valve, right? Yeah, and this system here too. So see, look at this one for instance. So let's label them. This is 1, this is 2, this is 3, oh, this is 3, and then this is 4. All right, fine. So we are looking at 2 here. So when we look at 2, you see that there are a whole lot of different things introduced, right? So we are just going to look at the components of what it's saying. So clearly we know here is the input, right? Let's see. This one here is the input, temperature and flow rate. A thermocouple means that it's basically a sensor, actually kind of like doing temperature recordings, right? And then this one too, we know is a control valve, and this is the controller, right? And we'll talk about all this. And this basically kind of like a system, right? A set point that we can kind of like do input into the system, right? So all the way showing the diagram to is that this particular system, we want it to come out at a particular flow rate and at a particular temperature, right? So basically what it does is that we check what is happening in the system, right? We record what's happening in the system with the sensor, the thermocouple, right? And then before even the system starts, we introduce a particular temperature into the system. Oh, that I want the system to be at a particular temperature. So if the thermocouple checks and the temperature, there's a temperature difference, it could be that the temperature, there's been a plus, there's been a temperature decrease or temperature increase, right? And this controller here is basically the intelligence behind the whole system that says that, oh, there's been an increase in the temperature or there's been a decrease in the temperature. So this controller here is what sends signal. So you see this line here, this dash line here, is sending a signal to this, what do you call it, valve here, right? Yeah, so this is the controller, and this is what we call the final control, because it's what executes the system, execute the signals from the controller to say that, oh, the temperature is above or below what we want. So then decrease this heat, decrease or increase this heat within the system. So just to make sure that we are in this stable state that we talked about. Where is it? This stable state here, this line here. So that if the reaction happens at a particular temperature or any other condition I want it to be, right? Yeah. So the same thing is happening here, just that different, all these different diagrams, some of them are being controlled differently, right? So as you can see, some of them we put the sensors at the beginning, some of them put them at the end. So here we have a level measuring device, right? Still a controller here. This is a valve, there's a heating element, and this is where we put the input, right? A controller here as well. But then there are different ways of doing it, right? So this one now we the diagram 2 for instance. So let's see. This diagram 2 for instance is what we call this diagram 2, right? Is what we call a minute. Yeah, so this diagram 2 is what we call a feedback system or a feedback control, right? Feedback. And it is so because we measure what is in the system, right? And then we go back and control the variables that we can control, the input that we can control, to make sure that the system is at steady state, or what we want to control is at where we want it to be or very close to it, right? So feedback. So we are measuring what's in the system. This here again too is a feedback system, right? What is it? Yeah, this diagram 32 is a feedback system. Why? Because we go to the output, right? So here, this is the output, right? Because we hit here, and then the temperature in this one here is the output, right? And in diagram 3, for instance, we do the heating here, and even how what is it, the height of the fluid here is also as a consequence of what's happening here, right? So we measure the height, and we also, yeah, so here we're just measuring the height, and then we see how whether it deviates from where we want it to be, and the control decides and send the signal to this, whether to control increase the flow rate, right? So whether to increase the flow rate, to increase it, or to decrease the flow rate, right? For us to maintain how we want the system to be. So this here too is also what we call a feedback control, right? There are a whole lot of different types, right? But then what we have in example, figure 4 is what we call a feed-forward control. So you see all this here, so let's see. We know clearly that these ones are the input, right? So you see, we are not measuring anything concerning the output here. We are still concentrating on the input. So basically, we've described the systems already, the system already using an equation. And we know that if the temperature or the flow rate exceeds a particular limit or gets a particular limit, it will deviate from how we want it to be. Right? So we can. So basically, what the feed forward. So here is what we call the feed forward control. What it does is that it predicts, right? It makes predictions and control the system. So here is what we call the feed forward control, right? So basically the system has been described already, and then it makes prediction and knows that, oh, if the temperature or the flow rate x goes increases to a particular a particular value or decreases to a particular value, we won't have this system here, or we won't have this output how we want it to be. So it basically makes predictions, so right, it makes predictions, and then that's the controlling just everything on the input, right? So yeah, so everything on input. So in systems like this is what we call the feed forward control, right? The feed forward control.